Now we are going to use the PPS sampling to select the clusters in cluster sampling. A natural choice of the size measure is MI because MI so the good size measure it should be proportional to PI, right? And TI is equal to MI, and TI is MI times y by I, and y by this is unknown. So if you choose MI, then and then we kind of believe that here, MI is proportional to TI. So anyway, that MI is a good choice of the size measure for PPS sampling, and then we compute the draw probability of cluster using MI information. By the way, the normalizing. So sum of the MIs over the whole cluster population is equal to the population size, which is N, capital N. And then for sampled cluster, if the cluster is sampled, then we observe the total sum of the y's in cluster I, because it's a single stage cluster sampling. And then we use Ti divided by Pi if the cluster I is selected at the case draw and construct capital T hat. So we'll now use a toy example to illustrate the PPS sampling for the design that we introduced. The finite population is the student registered in the introductory stat 101 course. The course has 15 classes, so this is the number of clusters. So this is a cluster, and student is element, right? It's element, and the goal is to estimate the mean study time per student on stat course or something like that. So the sampling frame is simple. It is a list of 15 classes. So we have 15 classes, and class size is something like this. So the total number is 647. So this is capital N, right? So we know the total students, but we do not have a list. We do not have a list of students. So suppose that we use PPS sampling to obtain 5 sample classes. So that is the draw. We draw for each draw. In the first draw, we select class 12. Second draw, we select class 14. Third draw, we have a duplication, something like that. Okay. And then this is actually MI divided by N, right? So the N is 647, and MI should come here. So we don't know. So that means class 12 is supposed to have 24 here. Okay. 14, we have 100, right? 144. So this is compute. You can compute it from the sampling frame, and then this one you can obtain from sample, right? This one is from frame. And then once you have this, then you can construct this one. It becomes T hat K, and this is K equal to 1 to 5. So that is the structure. So then using this sample, you can estimate the average the amount of time students spend studying statistics. So you use this sample to obtain T, estimator of T, capital T. So that is the sum of all the average of this, right? Sample mean of this, which is this one. And then we use this number, and then divide by 647, which we end up getting this number. So that is the estimated mean, and then the variance, estimated standard error, should be, so let's first compute the total estimator. So that is the 1 over n st square, right? So that is this 1 over 5, and then this is the sample variance of t hat k. So that's this one, and then you take the square root, and then standard error we should divide by capital N, which is 647. So this is your standard error.